Hey everybody, happy snow day. I am sorry we can't do this in person, but we are going to make the best of it. Today's topic is randomized experiments. And before we dive in, I wanted to actually give you a heads up on 3 extra credit opportunities. All right, now, the first one is Wednesday. We're going to have a review quiz in class. It is similar to the quizzes that you took the quiz that you took online at the very beginning of the semester, which was just about math. This one actually is multiple choice. You'll get, I think it's 45 minutes to do it. And it'll be in class. And if you complete it, you get a half point on your numerical score at the end of the semester, and I'll use that before I compile your letter grade for the class. Your performance on the quiz has no effect on your grade. Performance has no effect on your grade. But I still want you to put in a really good effort, because if you do, that will tell me how much you actually know and where the soft spots are, so that next Monday when we do our review session, which is our last day of class, I will know what I need to emphasize. It'll also just give me a good objective measure of how much you've learned over the semester that I can use to compare to times when I teach this class in the future and I make changes. And it'll give me a way of telling whether or not those changes I make actually make a difference. So I'm going to say, but please put in a good solid effort. That'll be good for you this time around, but you'll also pay it forward, which would be great. Okay, but that is not all. You get the half point for the review quiz. There will also be an online demographic survey where I just ask you some very basic questions. And again, that's you'll get a half point for that. And I'll use that to determine that'll help me measure kind of who's learning what in this class. And if there are certain groups, say the econ majors or the CS majors or whoever, who are not keeping up, I would like to know that so I can do something about that the next time around. And finally, I would really like it if you filled out the course evaluation for this course, because I learn a lot from those. But those are anonymous. These are anonymous. And so I can't just give you points for filling them out. So instead what I do is I give everyone a half point if more than 80% of the class actually fills out the course evaluations. In the past, that's worked pretty well. And remember, this class, it's not curved. And so these things, they actually have an effect. Even if I'm giving a half point to everybody, that has an effect. It doesn't just shift a curve. So 1.5 points, that's a lot. And it would be great if you would take advantage of all 3 of these. All right, on to experiments. Okay, so today I'm going to try to convince you that randomized experiments are incredibly useful. They solve a lot of problems that you might not realize until today or even there. But there's a lot of notation and a lot of jargon that goes along with it to explain why they work and I guess how they work, although the how they work is pretty simple. You randomize your subjects into 2 groups. You give one the treatment. You give the other something that's not the treatment, if anything at all, and you compare the outcomes. But why it works and why you'd want to do it, well, that's where all this notation comes in. We are going to work through all of this stuff in a substantive context, and that's going to be online advertising. In fact, we're going to talk about two studies. One is published in the Harvard Business Review, and it's a one-page study, and it's on Canvas, so you can go and take a look at that right now if you want to. Maybe hit pause and check it out. The other one is a much more involved study. I think it's published in something like the Journal of some sort of marketing. And that's a randomized experiment. And that's Lewis and Rayleigh. And that one was published in 2014. The HBR article is a little older. It's 2008. All right, so randomized experiments, pretty great, but not perfect. There are for sure downsides to experiments, and I'm gonna kind of finish up on a downer, and tell you about why all economic research, all empirical economic research, is not experiments. Even though there are for sure people out there that think all economic research should be experiments. All right. Let us dive right in. Why do we care about advertising? Well, we care about advertising for a lot of reasons, and there are a lot of different kinds of people that have questions about advertising. So we can start with just the basics, which is business. Businesses want to know how much they should spend. Whether it's Coke or Pfizer or Victoria's Secret, they all have goods they want to sell, and they want to get the word out about them. And the vision is that you advertise to let people know about your products and build brand awareness and build positive feelings about those brands and products. So they buy. And well, the businesses, they want to know how much they should spend, and so they want to know what those effects of the of exposure to advertising, what are the effects on consumer behavior, in particular purchasing behavior. Now, the psychology marketing folks, they want to know not just how does the advertising affect your bottom line purchasing behavior, but they care about how advertising makes us feel. Okay, the economists, well, we care about advertising too, but we think about it a lot more simply. Okay, we think about it as advertising can do two things. It can give people information, so you don't know that Coke actually tastes really great, and so we're going to let you know, and you might not know that it's super refreshing on a hot day, and you might not know what Pfizer's latest drug cures. On the other hand, it's possible that advertising doesn't just inform, it also signals. Okay, it signals what the brand stands for and convinces people, changes their preferences, makes them realize that if they drink Coke, they're cool. Or if they purchase Victoria's Secret products, people will think differently about them. If they're wearing a sweatshirt with a Nike swoosh, it changes how they feel. And it's not so much the information in the advertising as it is the effect it has on people's preferences. Okay. Well, today we're going to think about the simplest possible question, and that is, how does exposure to advertising, how does exposure to advertising affect consumer purchasing? Okay, that's the question we're going to focus on. Not the why, just we're going to try to measure the effect on purchasing. And in particular, we are going to focus on internet advertising. Okay, now, first study. Okay, as I said, published in the Harvard Business Review, and it's about it's basically an analysis of data that ComScore collected. They've got about 2 million people that are part of their, I don't even know what they call it. They have a group of 2 million people that they analyze. Now, these 2 million people, ComScore records all of their online behavior. Okay, ComScore installs software on their computers and records all of their behavior. And they actually also provide their identifying information so that ComScore can then tie their online behavior to their offline purchasing. So they have access to all of their credit card statements as well. Okay, but in return for this, these 2 million people get, quote, and this is from the article, various rewards such as free network backup or file encryption, which, to be honest, you can get for free already, and a chance to have their opinions and behavior influence the future development of the internet. Okay, so that's what these people are trading for. Basically, they're getting for their trading their information. All right, so here is what ComScore did. Actually, let me back up for a second. Let me also say that this was 2008, and things have become far, far more sophisticated in terms of tracking and how much information firms have about the people that visit their sites. And to be honest, it's a little bit scary. There's a lot more information, I think, that the firms have. And the people, at least these ComScore folks, they knew exactly what they were getting into. And they were jumping eyes wide open into the deep end. Whereas most people today, they don't actually realize, I think, just how much information that firms have on them when they go and visit these websites. All right, but enough about that. Here's what ComScore did. Okay, they, for several different brands, and let's, for example, one of them was sporting goods. They divide their sample, these 2 million people, into 4 groups. Okay, the first group is they call the control group, and that's the group that didn't see any ads at all on the internet. Okay, the second group saw online display ads. These are ones that just show up on websites that you go, and they used to be called banner ads, but sometimes they're not banners. The third group, they only saw targeted search ads. So since 2008 and even much earlier, firms can purchase certain search terms, say, for example, hockey sticks, and they can show their ads to people that search for those terms. Those are called targeted search ads. So, for example, you search for hockey sticks, and then Dick's Sporting Goods. Shows you ads for Bauer sticks that they sell on their website. Okay. And then group 4 is the group that saw both. Okay, both the regular old banner, display ads, and the search ads. Now, for each of those 4 groups, they look at 3 different outcomes. They look at how many visits to the advertised brand's websites, okay, there were. They look at sales revenue from online buyers. How much did the people that visited that website actually purchase? And sales revenue from offline buyers, because again, they can track, they know how much all of these people bought from Dick's Sporting Goods. All right, and now let me show you some results. Okay, here's the table, here's the graph. Now, the baseline, it was 3 groups which are the orange, the gray, and the blue. And for each of those groups, we show percent increase over the baseline group that didn't see any ads at all. Okay? Now, so for example, this first orange bar says that there's a small increase in the amount paid, or the number of visits, a small percentage increase in the number of visits to the advertised brand's website for those customers that actually saw an online display ad. Now, what I want you to do is take a look at these 3 questions. What did we learn from the results? What could explain the observed differences in sales from groups that saw no ads compared to the groups that saw the search ads? Okay, and then I want you to think hard about whether your answer depends on how the search engine, like Google, for example, at the time that Google was not the kind of by far the most popular search engine as it is now. I want you to hit pause, and I want you to think hard about these 3 questions, okay? And then once you've kind of thought it through, and ideally, you've got a friend with you and you can talk about it with them, or if they're not there, you can chat with them or something. But I want you to think hard about it before you flip to before I flip to the next slide. All right. So, let's talk. Now, what do we learn from these results? Well, if we want to be fairly conservative and not kind of jump to conclusions, what we learn, I think, at least what I learned from these results are, well, the people that saw ads, they bought more and visited the site more, visited the brand site more. Okay, now the question is why? Now let's look specifically at these search ads, because the search ads, we're seeing huge jumps. Okay, so more than 100% increase, so more than double the number of people in the group that saw the search ads visited the brand's website relative to the group that didn't see any ads at all. Similarly, they're buying way more, both online and offline. And so why is that? Well, I think what ComScore wants us to think in this article is that it's primarily the effect of the ads. Okay, that these people, they were browsing along, having a good time, looking at different hockey sticks. They see the ad and they get inspired. And they're like, wow, what an awesome hockey stick. What an amazing drug for the condition that I was searching for. What an incredible soft drink that is. I'm going to go purchase it. Okay, but let's step back for a second. Do we really think that the people who search for hockey sticks are comparable to the people that don't search for hockey sticks in terms of how much they would buy? Because I think that those that search for hockey sticks, whether they saw the ad or not, they were more likely to visit the brand's website, to purchase online, and to purchase offline. And so it could just be differences in characteristics. of folks that saw an ad versus those that didn't. Now, if Google didn't target ads the way they do, if they didn't just sell ads based on those search terms, if in fact they just didn't matter what you searched for, they just showed the same ad, then maybe the differences in the differences in characteristics of the folks that saw the hockey stick ad might not be very different from those people that didn't see the ad. Okay. But the fact is, if you search for hockey sticks, you're more likely to see ads for hockey sticks. And there's two effects here. There's the effect of the ad itself, which might be real and substantial, but there's this other thing, which is differences in characteristics. And we're going to call this selection bias. And that rears its ugly head often in economic analyses. All right. So, looks like if we just compare behavior of people that saw the ads versus didn't see the ads, especially for the search ads, we're not getting a pure causal effect. Okay, if in fact the revenue is higher just because the people who saw the ad were more likely to buy the products to begin with, we call that selection bias. Now, what we want to do is to be able to tell the difference between these two effects. What we would love to do is to have do this comparison of the behavior of the two groups and split it into two effects and identify what's the causal effect of the ad and what's the selection bias. And to do that, even just to talk about it, we're going to need some notation. All right. This is probably the most important and trickiest thing I'm going to talk about in this whole lecture. And that is Y0I and Y1I. Okay, we're going to go slow at first. Okay, this Y0I and Y1I, these are both defined for everyone. Okay, so if I've got a student here, let's suppose we've got a student named Bjorn. Okay, here's Bjorn. Hi, Bjorn. Now, Bjorn may or may not like hockey. Okay, but there's some amount he's going to purchase, some amount of hockey equipment he's going to purchase if we don't show him an ad. Okay, so let's say Y0I for him. Let's say if he doesn't see an ad at all, he's going to spend maybe $20 on hockey equipment. But if he does see an ad, then maybe he spends a little bit more. He kind of gets excited. $25. Okay, now the whole key here is we're only going to observe one of these two. Okay? If he sees the ad, we're going to observe this. Oh, this is only observed if he sees the ad. Okay? And if he sees it, we're going to say that DI is 1. Okay? So, we're going to be able to observe Bjorn's purchases. And if he sees the ad, if DI is 1, then we're going to observe Y1I, which is how much he purchases if he sees the ad. It doesn't mean Y0I doesn't exist, it doesn't mean we can't talk about Y0I. That's how much he would purchase if he didn't see an ad. So we only observe this if he doesn't see the ad. That is when DI is 0. Okay. So, All right. Y0i, Y1i, and DI. Those are the pieces we're going to be working with. Okay? Now, what we want to know is this right here. Okay, we want to grab somebody randomly in the real world, and ideally, what we want to know, what we would love to observe both Y1i, what would this person purchase if they saw the ad, and Y0i, what would this person purchase if they didn't see the ad. And we want to know what's the expected difference between those two. Okay? We're going to call that the average treatment effect. Okay, that's this right here. For any particular individual, Y1i minus Y0i, that's the treatment effect. Can we ever observe it for a particular customer? No. We can never observe this. Can never observe this. But we still want to estimate this. This is also called the ATE, average treatment effect. All right, that's what we want. Now, let's suppose that we had a magic device that could look inside people's brains and tell us what Y0i and Y1i are. And we've got these 4 people. Estimating the average treatment effect is easy here. Okay, how do we do it? Well, first of all, let's take a look at this data and notice that these people right here, these person 3 and 4, they like hockey. They're going to purchase no matter what. And then if they see the ad, they'll purchase a little bit more. Person 1 and 2, they like hockey a little bit, but not really. And if they see the ad, it's not going to change their behavior at all. Okay, so what's the effect? Take a moment and see if you can figure out what the average treatment effect is. All right, did you do it? I hope so. Okay, you're only cheating yourself if you don't try to do it on your own first. Okay, so we've got 4 of these. We've got 50 minus 50. Okay, that's person 1. We've got 40 minus 40. That's the effect for person 2. We've got 110 minus 100. And we've got 160 minus 150. Okay, this whole thing is 20. But we need to divide it all by 4. Get the average. Okay, average treatment effect, it's 5. You show a random person an ad, you can expect their purchasing to go up on an average of $5. Okay? But remember, we don't actually observe both Y0i and Y1i in the real world. All right. So let's think about what we actually observed in that Harvard Business Review study. Okay, well, we only observed one of these 2, Y0i and Y1i, for each individual. Some of the people saw the ad. The hockey fans, they searched for hockey sticks. They saw the ad. And so what we observed for their purchasing was Y1i. They saw the ad, and so that's what we observed. The non-hockey fans, they're not searching for hockey sticks. And so what we observe for them is just Y0i. Okay? And so what happened when the HBR study actually compared outcomes of the people that saw the ads to outcomes of the people that didn't see the ads? Okay? Well, they're not actually comparing they're not computing. This is not the expected value of Y1i minus Y0i. Okay, the conditional expected values. It's expected value of yi given you saw the ad, and the expected value of yi given you didn't see the ad. And so what they get is they compare this, the average for those that didn't see the ad, that did see the ad, to the average of the people that did, and what they get is a 90. Oh my God, what a huge effect of advertising. 90. But how much of that is selection bias? Well, 85 of it is selection bias, and only 5 of it is the actual causal effect of the ad. So in this class, whenever you compare outcomes of people that got the treatment and didn't get the treatment, even when you've got selection bias, I'm going to call that the HBR effect. No one else calls it the HBR effect. That's our little secret term that we use in this class. Okay? You go out in the real world and you say, oh my God, that's not the actual effect of the treatment. That's the HBR effect. No one will know what you're talking about. But here we can talk about it. And it's nice that it has a name, I think. So this is what it is. The HBR effect is what you get when you compare outcomes for a treatment group and a control group. Now, this is actually fine as long as the treatment is independent of, well, we'll get to that. Sorry. All right. This expected value right here, when DI is 1, we know that YI is just Y1I. Okay? And so if Y1I and DI are independent, and Y0I and DI are independent, then we're in good shape. Okay? But the fact is these conditional expected values in general are not equal to the unconditional expected values. And so you don't get an average treatment effect. You get something else. Now, why is that? Well, let's think about 2 things. Okay, first, all right, what is this thing right here? What do you think it is? This is Y0I. That's, and I want you to think hard about this. Maybe even hit pause and try to piece this out on your own first. Okay. Now think about Y0I. That's what you would purchase if you didn't see the ad. And this is weird. We're conditioning on seeing the ad. Okay, that's weird. But let's go back to Bjorn. Okay, Y0I, it exists for Bjorn. We just can't observe it. But we can think about it. We can say those people that saw the ads, the ones that searched for hockey sticks, this represents what Bjorn would have purchased had he not seen the ad. Okay? This represents, okay, so this is not observable. Just because we can't observe it doesn't mean we can't think about it. Now this right here is observable. Okay, and that's for all those people that didn't see the ads, the ones that didn't search for hockey sticks. How much did they purchase? How much would they purchase had they not seen the ad? Well, they didn't see the ad, so we can observe it. Okay, this difference right here has a name. We're going to call that the selection bias. It's for the 2 groups. If neither of them saw the ad, what would the difference be? Okay, if we go back to that table, that's the difference between the hockey fans and the non-hockey fans in what they would have purchased had neither of them seen the ads. Okay, super nice. The selection bias, it's a super nice thing. We don't usually get to observe it. Sometimes we do. Usually we don't. Now, what about this thing? Okay, here the first term, totally observable. that's for those people that saw the ad, how much would they purchase? Okay, observable. Okay, how much did the people that saw the ads, the hockey fans, okay, the hockey fans saw the ads, how much did they purchase after they saw those ads? And then this part, not observable. Same group, it's the hockey fans. How much would they have purchased had they not seen the ads? This is a lot like the average treatment effect, but it has a different name. It's because we're conditioning on the hockey fans. This is the effect of the ads for the treatment group, okay? And we're going to call that treatment on the treated. It might be the same as the average treatment effect. Okay, maybe these ads, they're equally effective for the hockey fans and the non-hockey fans. But in general, they might not be. Okay, this is a really good reason to think that these ads for Bauer hockey sticks, they're way more effective for hockey fans than they are for non-hockey fans. Okay, in which case the treatment on the treated will be bigger. And in that toy example we had, the treatment on the treated was actually 10, okay, whereas the treatment for the non-treated, the treatment effect was 0. And so this is not the same as the average treatment effect. Okay, but it sure is a lot more useful than the HBR effect. All right, so what is that HBR effect? Well, let's see what happens when we add that selection bias thing that we just defined to that treatment on the treated thing. Okay, so here's the treatment on the treated in the orange, and here's the selection bias in the green. When we add them together, you know what happens? Well, what happens is that this term right here and this term right here, they cancel out. Okay? And what we're left with is the HBR effect. Okay? That's the HBR effect. And so what is the HBR effect? What is the HBR effect? It's the selection bias, the differences that already were there, plus the effect of the treatment on the treatment group itself. Okay. We don't know how much there is. We can't divide them up easily. Okay. But actually, if you take applied econometrics next semester or sometime in the future, or you take the regular econometrics class, you'll learn a method called difference in differences, where you actually use data to estimate the selection bias. You use data to estimate the HBR effect, and you subtract the two, and what you're left with is an estimate of the treatment on the treated. And that can be useful. It can be pretty useful. We're not going to talk about that method today. Instead, we're going to talk about randomized experiments. Okay, so this HBR effect, we got two problems. First, the part that's the treatment effect is just measured for the subset. It's not the whole population. And two, the HBR effect is corrupted by the selection bias. Okay, so we're getting this like weird thing that's not useful at all. Now, if we can control who sees an ad and who doesn't, we could assign that treatment randomly, independent of the outcome. And if it's independent of the outcome, if that treatment is randomly assigned, we just flip a coin, heads you see the ad, tails you don't, then what's going to happen is this conditional expected value is going to be equal, well, that conditional expected value is going to be this conditional expected value. That's just by definition. And that conditional expected value is going to be equal to the unconditional expected value. And so when you have a randomized controlled trial, all you have to do is compare the average outcome for the treatment to the average outcome of the control. And that is your average treatment effect. All right. The beauty of this whole thing is that when the treatment's randomized, the HBR effect and the average treatment effect are the same. If the treatment's not randomized, they are usually not the same. This is exactly what is becoming increasingly popular in empirical economics, and that is to actually do a randomized field experiment, okay, where you randomly vary the treatment. You make sure, usually through just randomization, that the treatment's independent of any unobserved determinants of that outcome. Okay, whether or not you're a hockey fan has no effect on whether or not you get the treatment. These experiments, they're a lot like the lab experiments that doctors do to test out new drugs. Okay, huge amounts of the research that happens in development economics are randomized experiments. Political science, people are doing more and more of these. Psychology does these all the time. Marketing is doing them. Randomized field experiments, I keep thinking the pendulum is going to swing away from them, and it just keeps moving toward them. Field experiments, super, super popular, because they give you an unbiased estimate of that average treatment effect, which is what you want. All right. So what you've all been waiting for is what Lewis and Rayleigh do and report in their 2014 paper. And that is they actually do a randomized experiment where they randomize who gets to see the ads and who doesn't get to see the ads. They start out with a very large sample, not quite as big as the 2 million of ComScore, but still quite large. They did this with Yahoo and a major retailer. They don't tell us who it is, but we can, for the purposes of today, just imagine it's Dick's Sporting Goods. And they start off with 1.5 million Yahoo users that they could match against that retailer's offline sales. They divide up that 1.5 million, or about 1.6 million, into a treatment group and a control group randomly. They don't have to be the same size. Okay, that treatment group is 80% of them. They wanted to show the ads to most of them, and the control was what was left. Okay, totally reasonable experimental design, as long as you have enough in that control sample, and they for sure did. Now, whenever you're evaluating whether an experiment is good, whether you're putting it together yourself or you're critiquing someone else's, one of the first things you want to do is think about, who does this sample generalize to? And do we think that Yahoo users are just regular people? Or do we think people that use Yahoo regularly might be different from the general population? Because what we're learning here is something about Yahoo users, and that may or may not generalize to the general population. All right. So back when this study was done, this is what the Yahoo front page looked like. And the ads that we're talking about are these right here. Okay? They're display ads, and they show up randomly, sometimes randomly, just on that top page of the Yahoo website. Now, whenever you look, the next thing you want to do when you're kind of seeing if an experiment makes sense is to look at the characteristics of the control group and the treatment group and see if they look like what you think. So here we've got 59.5% of the control group is female and 59.7% of the treatment group is. That looks pretty good, okay? It was random. Whether you're in the control or treatment should have nothing to do with your gender, and so we should expect to see very similar percentages in both. Okay, so now let's look at that next line, the retailer ad views. Okay, the control group saw none. Excellent. That would be weird if it wasn't 0. They shouldn't be seeing any. The treatment group sees, 63.7% of the treatment group got to see an ad. Now, why is that? The treatment group, I thought they should be 100%. Why isn't it 100%? Well, we don't know if those particular people assigned to the treatment group are actually going to the Yahoo websites. I have a Yahoo account. I could have been in this study, and I never go to the Yahoo webpage. Okay, so I'm never going to see the ad. So only 63% of the treatment group actually saw the ads. Now, what about the Yahoo page views? Okay, it turns out that 76.4% of the control group actually went to the Yahoo front page, and 76.4% of the treatment group did. That's great. Those numbers, they should be very, very close. They don't have to be exactly the same, okay, but they should be very close, and they are. Okay, the treatment and control group, neither one is more likely to go to the sites. Page views per person look pretty darn similar. Ad views per person, 0 for control, 25 for treatment, great. Ad clicks per person, 0 for control, good, 0.056. Okay, per person for treatment, great. So this is good news. Things make sense. Let's keep moving and take a look at some results. Okay, now, the people in the study, a huge number of them didn't see any ads. Okay? Some of them saw a lot of ads. Remember, and then note that in this figure, which is pulled right out of the paper, 2.4% of the exposed individuals saw even more than 200 ads. So when we compare the revenue outcomes of the people in the control group and the people in the treatment group, what are we actually getting? Okay, what is the treatment here? The treatment, in some ways, is just being in the treatment group. But the difference between the control and the treatment is not the treatment group all saw exactly one ad. There's quite a bit of variation here. Okay, the treatment group actually saw an average of 25. And so what we're really seeing, in some senses, is the effect of seeing about 25 ads, but not just the effect of an ad, okay, which might be what we actually want. All right, so here are the results, okay? We've got, for the control group, we've our 300,000 observations, and for our treatment group, we have about 1.3 million. And in this table, what we see mean sales before the campaign started, and we see mean sales during the campaign, and we see the difference. Okay, there's a lot of numbers we can take and subtract from each other. We can take a lot of different differences here. And so what I want you to do now is think hard. Okay? Well, sorry. In a second, I'm going to have you think hard about what it means to actually subtract some of these numbers from other numbers and how to interpret those results. Okay, but before we do that, I need to introduce one more definition, and that is the intent to treat effect. Okay? So when we compare the treatment group to the control group, and not everyone who's randomly assigned to the treatment actually gets the treatments, we would like for everyone in the treatment group to get the treatment. We intend for everybody in the treatment group to get the treatment, but they don't always. And so we're going to call that difference between the treatment group and the control group the intent to treat, when not everyone actually gets the treatment. And you can think of the intent to treat effect as an underestimate of the treatment effect, of the effect of the treatment itself. Okay, you think about it as a lower bound on the average treatment effect. You could also think about the intent to treat effect as the average treatment effect for a different treatment. where that treatment is assignment to the treatment group. Sometimes that's interesting, sometimes it's not. So, let's think. If I take mean sales for the control group and during the campaign, and I subtract mean sales for the control group before the campaign, which of these do you think I get? And take a moment to think about that. Okay. Well, there's no way it's the average treatment effect, because no one got the treatment. Okay, we were only looking at the control group, so it's not going to be that. Okay, the selection bias. Well, selection bias is the difference between who got the treatment, between what people would have purchased had they got the treatment. Sorry. It's what the treatment group would have purchased had they not got the treatment minus what the control group would have purchased had they not got the treatment. The selection bias, this is actually, you could estimate this here with C minus A, because this is a case where we actually do observe, in some sense, what the treatment group would have done had they not seen the ads, because we've got this observation from 2 weeks before. Now, intent to treat, that's actually what we have here. Intents to treat, again, that's going to be the difference between the outcome for the treatment group and the control group if, in fact, the treatment group didn't always get the treatment. Okay, that's not what B minus A is at all. B minus A, that's change across time unrelated to the treatment. So what happens with the control group before and after? All right. So what's D minus B then? Hit pause and see if you can figure it out. All right. Well, D minus B, we know it's not change across time not related to treatment because, well, that number D, that D group, that's the treatment group actually getting the treatment. That's the treatment group when they were actually during the campaign when they could potentially get the treatment. But some of them didn't get the treatment. So it's not going to be the average treatment effect because some of the treatment group didn't get the treatment. And so what we're left with is it's got to be the intent to treat. And in fact, that's exactly what it is. It's the difference between the treatment and control group when they've been exposed, when the treatment group has been exposed. But some of those treatment group people, they didn't actually see an ad. All right. Let's take this to another example. Okay. Now, this is more hypothetical. Okay. But what I want you to think about, when I was in college, a lot of my friends would go to their final exam wearing pajamas. Okay. I never went and took any exams in pajamas. And as far as I can tell at Cornell, it's not super popular. But when I talk to my friends, that kind of makes some sense. Okay? It looks pretty relaxing. You're saving time. You're not actually having to put regular clothes on. Okay? Maybe you get there quicker because pajamas are loose and comfortable. Okay? Maybe there is a causal effect of wearing pajamas on your exam score, and maybe it's strong and positive. Suppose we actually wanted to figure this out. Okay? Suppose we want to know the effect of wearing pajamas on final exam scores. And so what I'm going to do is I'm going to compute the average score of all the people that take the final exam in this class in their pajamas. And then I'm going to take the average score of all the people that don't wear pajamas, and I'm going to take the difference of those two. And so take a moment, talk to a friend, and think hard about what you've estimated, or what I've estimated if I go ahead and I do this. All right, let's see what you got. Well, we know it's not the average treatment effect, because last I checked, those students who wear the pajamas to the final exam, they're pretty different already from the students that don't wear pajamas. I don't know if they're better students. I don't know if they're worse students, but they're different, and it wouldn't surprise me at all if they were systematically scoring differently, having nothing to do with the actual pajama wearing. So it's not the average treatment effect. Treatment in the treated, selection bias, intent to treat. Well, we're comparing average scores of a treatment group and a control group that aren't randomized. This is clearly the HBR effect. Okay? And that's none of these. All right. So let's see if we can come up with a better way. Okay, so now what I'm going to do instead is I'm going to do some randomization. I can't just randomize pajama wearing. Okay, that would be very difficult to get through the institutional review board that watches out to make sure that I'm not doing unethical things in my classes. But what I might be able to get through the board is a random allocation of tickets. Okay, so what I could do is I could flip a coin for each student in this class. Heads, you get a pajama ticket. Tails, you don't get a pajama ticket. And you're only allowed to come to the exam wearing your pajamas if you've got a pajama ticket. So let's suppose I go ahead and I do this. And now I compute the average score of the pajama wearers and subtract the average score of the non-pajama wearers. Now what have I estimated? All right. The key thing here is we have not randomized pajama wearing. We've only randomized pajama tickets. Okay? It's still the case that there's some choice here. Among those students that got the tickets, most of them, frankly, they're choosing not to take advantage of getting the ticket, and they're just wearing their regular clothes. And the ones that got the ticket, that are wearing their pajamas, they're different. And so those pajama wearers are still systematically different from the non-pajama wearers. It's a little bit better, but this is like some slightly better HBR effect. Okay? The pajama wearers are not random. Lots of students, they look at this and they think that this is it. That is not it. Okay? We do not have an intent to treat effect here. All right, last one. Same randomization. We randomly allocate the pajama tickets to students. We only let the students with tickets wear pajamas to the exam. And now what we're going to do is we're going to compute the average score of the ticket holders and subtract the average score of those students who are not randomly assigned tickets. Now what do you have? Okay, and I promise this is the last time I play the music. All right. So, do we have an average treatment effect? Is it true that our treatment group, who are those that got the tickets, are guaranteed to have the treatment? In this case, the treatment is wearing pajamas? No. We do not have an average treatment effect. Is it selection bias? No. It's definitely not selection bias because there are definitely people that are wearing pajamas that we're comparing. Okay, it's not treatment on the treated. This is intent to treat. Okay, it's not a great intent to treat estimate because those ticket holders, most of them probably won't get the treatment. And so we're going to get this difference. If we see a positive difference, it's a lower bound on the pajama effect, the average treatment effect of wearing pajamas. But technically what we've got here is an intent to treat effect. Now, there are better ways to exploit this. If you take applied econometrics, you can actually use a randomization strategy like this and combine it with a method called instrumental variables and get a pretty good estimate of the effect of wearing pajamas on final exam scores. But with the methods we've got in this class, we've got an intent to treat effect. All right. Experiments are pretty great, but they're not perfect. There are at least 4 downsides to experiments that I want to talk about right now. Okay, the first is it's often the case that the population covered is not the population of interest. Okay, pretty often you'll do an experiment with one small group and then want to generalize to a much larger population. This actually happened in real life. It happens all the time in development economics. It's pretty controversial, actually. The best example is a few years ago, there were some tests of the effects of deworming medicine and using a randomized control trial, and the effects were huge, but they were only one set of villages in one country. And based on those results, a lot of money got invested into deworming programs when the effects of the deworming were actually a lot smaller. It ended up turning out they were a lot smaller in most places. And actually the original sample where the experiment was done didn't generalize as nearly as well as the authors thought it would. All right, second, sometimes the treatment, it's not exactly what you want. Okay, sometimes you don't have enough money to really do a big treatment of the type that you actually want to roll out, or you do something like distribute some medicine, but it's not exactly the medicine that you want to, that'll be involved in the big, the policy when it gets rolled out. You see this pretty often in school interventions where a group will say, hey, we have a really great idea. We want to do this thing in the school. And they do it, and they do a fantastic job implementing the program, and it has a big effect. And then when they go to expand that thing nationwide or statewide, it doesn't get rolled out as well. And the treatment that actually gets rolled out is not as good. The people they hire to do it are not as excited about it. They're not as well trained. And the effect you get is a lot smaller than the effect you observed in the experiment. So several years ago, I was teaching a course in development economics, and I wanted my students to think hard about to just think about a program that they wanted to evaluate in a developing country. And I wanted them to go find real programs that they wanted to evaluate. And I had a student come up to me after class, and he says, there's this amazing milk subsidy program in El Salvador that he was very interested in. But he was concerned because he didn't know how to evaluate it because it hadn't been set up as an experiment. And so his take was, well, if you can't use an experiment, then it's impossible to evaluate it. And it's true that if you haven't set up the program for evaluation from the beginning as an experiment, as in randomize who gets the treatment and who doesn't, then you don't have an experiment. But that doesn't mean that experiments are the only way to evaluate social policy. There are lots of ways to evaluate social policy. And in fact, if you take applied econometrics, you'll learn 6 or 7 different methods for estimating the effects of some treatment, be it a social program or whatever, without an experiment. Because there are lots of cases where you want to evaluate something, but you don't have an experiment. And then finally, the fourth one is maybe the most obvious, and that is that experiments are expensive. We're talking about a lot of data collection, careful randomization, making sure as many of the treatment group people actually get the treatment, and making sure that none of the control people sneak over and get the treatment. It's a lot harder to actually implement one of these things, and a lot more expensive than you might initially think. Okay, doesn't mean experiments aren't great. In fact, experiments in many ways are still the gold standard. But it doesn't mean there aren't other ways to evaluate things that can be better on a lot of dimensions. All right, that is it. That's the last of the new material for the semester. When you come to class on Wednesday, you'll take the review quiz, and once you take that, I will analyze the data, and then on the following Monday, and that's the last day of class, we'll actually do a review. That'll be our review session, the same style that you've seen before each of the 2 prelims. And there'll be lots of office hours during the time between that class and the final exam. And good luck. I don't expect you to study for the review quiz. I'm hoping that a lot of you have been keeping up already. And I hope all of you come on Wednesday and put in your best effort. All right. Thank you very much. See you on Wednesday.